Right, so now you should have Cisco Packet Tracer installed now. As you can see, I've got just a little bit of devices and some text. Now, I've made this, don't worry if you don't have this, everything's okay. You should have a blank screen. Now, so basically what we can have, I'm not going to show you these because they don't have any text and you might not know what they mean. So let's go through the top. So now the first thing is file. This is just some basics. So we have new, open sample, save as PKZ. PKZ is basically an extension of Cisco Packet Tracer. It's like exe of Windows, right? Executable or PDF for like when you have CVs. It's something like that. Print, exit, logout, exit, nothing really important. Edit, now this is important if you want to undo something. So undo, redo, copy, paste. You could use Control C, Control V. I use Control C, Control V. And Linux will be Control C plus Shift, Control V plus Shift. Options, this will be important for later because I need to show you one thing. Actually, I can show you right now. Preferences, and now if you go to preferences, you can change some fonts, you can change some, you can change some stuff, hide stuff, miscellaneous, answer tree, nothing really important. I've never actually been here because I've never had the need. However, I want to show you is interface, and now you'll have an option, show device model labels, and if I show you this, I will show you something like this. I will show you the models that you have. Now, this is not really important. It could be important if you sort of open someone else's and you would like to know what devices they're using. However, if you click on it, it will still show you what device it is. So it's not really useful. I like to have it turned off because it annoys me. What you can also do is hide the labels. For example, you can set router and it hides it, and you can hide both. But I don't recommend doing that because then it shows. Now, what I'm going to do is I'm going to hide the model labels because I like to have it clean like this because I usually set my own names. Basically that's it. So the first thing I'm going to show you is a router. Now the router is accessible through network devices, routers, 1941, which should be, sorry, it's right the third one from the start, right? Router, the same router. I'll show you how it looks like. This is how a router actually looks like. This is like a networking router. This is not your home router. Your actual home router, I'll tell you this on the second when I'm talking about a switch. Your home router is an actual switch. It's not a router, right? So as you can see, Cisco 1941 series. It says the model. You can put some extension cards. However, it doesn't always work for some reason. If you want to do some extension cards, all you have to do is just turn it off and put the extension cards, which is one of these ones. For example, you can put this one. There you go. However, I'm going to remove it because, as I said, it doesn't work all the time. So let's just turn it on. Now, every time you turn it on, what happens is it has to start up. And every time you turn it on, every time it starts, everything is get lost. So if you put your default gateways, which I would love to here, if you put them here, the IP addresses, you have to do it every single time. You'll have to basically put it in again because it loses all the data, which is bad, but right. So this is a router used to connect two or more different networks together. Now there's a little space, I don't know why it happens, but operates by default gateway. Default gateway is basically the router's address, right? So when you go to your own network and you go in the browser, you type in 192.168.1.1 or 1.0. It'll basically go on it'll basically give you some options, right? It'll give you some. It could be a different IP address, however, I don't think it is because it's usually 192.168.1.1 unless you've changed it. So basically, when you go on it, you get some options. You can put some, you can change the stuff, you can see your overall network information, right? And that's basically, you can connect two different networks together. So for example, if you want to connect to your home network with your neighbor's network, well, you could easily do that by managing the default gateways and or by connecting cabling, right? Easy as that. Switches. Switches are basically the most important device in networking, more than routers, because routers are not as important as switches. Switches, I love switches by the way, you possibly will be able to tell that soon. So used in connecting multiple devices together, I'll show you in a second as well. So as you can see, this has 24 ports. Now you may recognize this from your home router. Now, as I said, your home router is not an actual router, it's a switch. It's just basically outputs Wi-Fi, right? That's all it does extra. Switch doesn't output Wi-Fi, right? So as you can see, basically you can have some Ports, it has 24 ports. I'm pretty sure you can expand, or different switches have more. I've seen, if I'm not wrong, I've seen switches with 48 ports altogether. Like, it was basically the whole wall was in ports, right? That is a lot of devices you can connect. Because remember, every single port, sorry, is a device. You can connect a device. And this will be used for administration or connecting power. Sorry, the administration, yeah, I was right. No power, this is power. So as I said, using connecting multiple devices together operates on MAC addresses, layer 2 device. Now, what is a MAC address? MAC address stands for Media Access Control, and is basically your computer's card, because basically as you can see, I'll show you. So basically as you can see, now every single port has a different MAC address. So every single sort of port, for example, your USB has a different MAC address, your Ethernet has a different MAC address, right? When I'm going to be talking about IP addressing, IPv4, I'm going to be possibly explaining a lot of MAC addresses as well, because they're basically very important with each other. So it can be connected with other switches, as I said, because you can basically, you can have a triangle of switches that could be used against basically problems, right? And it should be directly connected to a server or a router or another switch, but that matters what your needs are, right? How big is your network and stuff like that. Okay, so let's go to the right. Server is the head of the operations. He's in charge of the whole network. Every single request, every single basically IP address request, it goes through the server. And the server is in charge, and the server says, okay, you are allowed an IP address, and I'll send you an IP address, and I'm going to tell you what the IP address is, right? So, responsible for everything that happens in our network, dishes out IP addresses, responsible for services like DHCP, FTP, SFTP, mail, and other services. And it can host websites, it actually can. And domain controller. Now, domain controller is the main server in charge at the time. What this means is, if you were to have usually networks have 2 servers or even more, the big networks can have more servers. Why? The reason is because sometimes a server a server can get its power cut off. It can happen. What can happen is sometimes maybe whatever can happen. There's a lot of things that can happen. Millions of things. Someone can trip over, cut the wire. Guess what? You don't have a server anymore. What happens then? Instantly, another server, which is already configured, it just basically is whenever this one loses power, the other one becomes the domain controller, and he is now in charge of this network. That's something called redundancy. One server is basically given the charge to another one. It's like the king, right? One dies, the other one takes over. It's the same thing. It just takes over, right? It just keeps repeating itself. Or, for example, we could get DDoS, right? So the other one takes over. PC. A PC or a laptop, basically an end device or a client. This is basically the most basic device you can use in the network. A PC or a laptop or a computer or whatever. Hub. A much cheaper and worse switch can connect a few devices, operates on IP addresses, like this switch operates on MAC addresses, which is way faster than IP addressing, believe me. Your home router, basically. Yeah, this is basically home router. If you look at it, as you can see, it's a little device. Just zoom in. As you can see, it's a little device, right? It looks like your home router. So that's why I said basically this is your home router. Apart, as I said, the difference is your home router gives IP addresses. What am I talking about? Wi-Fi. This doesn't, right? And a repeater, and also it sometimes acts as a repeater to boost signal, and a repeater to basically repeat signal, because signal can only go, I'm pretty sure I can go 100 meters in cabling before it loses power. So on 90 meters, you should already have a booster. Repeater or booster. Oh, we can call it booster. A booster of signal to boost the signal, and then the signal goes back up to the highest voltage, and it keeps going, and obviously the longer it goes, the loses the signal, and we need another booster to boost signal, right? And that's basically it for the devices now. Right, so I don't think there's anything else to say for the devices right now. I'll be showing you devices, the purposes of them and no working. I just want to take you through the basics now. So I hope you enjoyed this short guide about devices. The second thing I'm going to show you is possibly cabling, how to network devices while cabling we're using and stuff like that. And possibly after that, we're going to do is some networking IPv4, because then I'll be able to explain stuff to you without me having to explain too much stuff at once. So see you in part 3.